Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a couple of example problems of how you can use the reaction quotient and compare that to the equilibrium constant in order to figure out which direction your reaction is going to proceed. Is it going to proceed to the left towards the reactants, or is it going to proceed towards the right towards the products? So let's go over our first example. So our first example is I have I2 in the gaseous phase plus chlorine in the gaseous phase, and that's going to go to 2ICl in the gaseous phase. And they give us Kp for of the reaction, which is 81.9. So the Kp is for pressures. So what do they give us? They give us pressures. So here we have the pressure for I2, and they give us 1.114 atmospheres, and they give us chlorine at 0.102 atmospheres, and they give us the product ICl at 0.355 atmospheres. And so what we need to do is plug this into our reaction quotient expression, and then compare that with the equilibrium constant that they gave us. So the first thing, we need to set up our expression. So the Kp is going to be equal to the product, which is going to be the pressure of the product, which is ICl squared, because of the 2 coefficient, over, need a new marker, over the pressures of I2 and Cl2. So there's coefficients of 1, so this is going to be just pressure of I2 times the pressure of Cl2. And so now all we need to do is plug in our pressures. So here I2, we have for ICl, it's going to be 0.355 atmospheres squared over the pressures of I2, which is 0.114 atmospheres multiplied by 0.102 atmospheres. And so you can see that the atmospheres are going to cancel out. And so if you do the calculation, it'll come out to 10.8. So this comes out to 10.8. And so now we're going to compare the quotient Q to the Kp value. So this should be Q, that we're finding the reaction quotient. So Qp is 10.8 compared to the equilibrium constant. So our Q is smaller than our constant, our equilibrium constant. So that's telling us that we have more reactant than product, more reactant than you would expect at equilibrium. So we got to get rid of our reactant. So that means it's going to go towards the forward direction, right? So it's going to go towards the products to get rid of reactant. So that way, so this tells us that our reaction is going to go forward towards product. Okay. What about this problem here? So here, again, same situation. They're giving us a reaction. This is N2O4 gas going to 2NO2 gas. And so they give us the Kc this time. So now we're gonna have to find the reaction quotient of this reaction given the concentration. So we need to find the Qc. So for the Qc, the expression again is going to be products over reactants. So it's going to be the concentration of NO2 squared, because of the 2 coefficient, over the concentration of N2 N2O4. Okay, so now all we need to do is put in the values. So here we have N2O4, or NO2, sorry. We're going to put 0.0255 squared over 0.0331. And now all we need to do is calculate that answer. And the answer is 1.96 times 10 to the negative 2. So this is going to be 1.96 times 10 to the negative 2. And so again, comparing the QC to the KC, our reaction quotient here is larger than the equilibrium constant. So since our quotient is larger, that's telling us that we have more product than what you would expect at equilibrium. So if we have too much product, right, if our product, we have more product and we have less reactant than what we would expect at equilibrium, so that means we need to decrease product and increase reactant, which means we got to go towards the reaction side. So it's going to go towards the left, towards reactant. And that's how you use, that's how you calculate the reaction quotient and use it to figure out whether or not you're going to go to the right or the left at this point in the reaction. I hope this was helpful, and if you like this video, please like, share, subscribe, hit the notification bell, and thank you for joining me. I'll see you next time.